Hello, everyone. And today, I would like to talk to you about the force of tension. So, tension force is a funny thing because there's no really specific formula for tension. Um, and that's because tension is kind of used in a variety of different situations, and the force will be calculated differently for each situation. So, just a couple things to note when we're talking about tension is that we're looking at cables that are very thin. So, we don't care about the width of the cable. So, width of cable is negligible. The weight of the cable is also negligible compared to the masses that we would be dealing with. And we assume that it does not stretch. So, tension is the force that occurs in a cable or in a string, and it's a pulling force. So, imagine if you were playing tug of war, you have two opposing teams, you're both pulling on the rope, trying to drag the other team across the line. The rope is super taut, and that's because there is a pulling tension force applied on both ends of the rope. So that is what tension is that you have to have basically forces acting on either side of the rope. Otherwise, if you only have one force acting on the side of the rope, then it can get very loosey-goosey, right? Like you've pulled a hose before, right? Or like a string or something gets very loosey-goosey. So there's no tension here. So tension is basically the force that's acting against a pull. So an example would be that if we have a box and it is suspended by a cable, and this cable is pulling up right here, you have your force of tension pulling up the crate, and we also know that gravity will be pulling down. So in this particular case, your tension force is acting against gravity. Another example could be if you have a box that's on a flat surface and you are pulling it along. This is your force of tension. Now, the force that it's acting against is actually the force of friction in this case. So here we have the force of friction acting against our force of tension right here. So for each of these different situations, your formula to calculate the force of tension is going to be different. So it really depends on how you analyze this different situations. So if we take a look at scenario 1, let's just temporarily erase this. Now, let's assume that this box is not moving. So this is staying still. We know that gravity is trying to pull it down, but it's not succeeding. And we know that tension is trying to pull it up, but it's not succeeding. The box is not moving. So the way that we would write this formula is that your force of tension is equal to your gravitational force, but it's in the opposite direction. So it will be negative Fg. If we look at this example again here, where we are pulling along the ground, and we have your friction force acting against it, let's neglect these forces here. So we have the gravitational force and we have the normal force as well. But we can ignore those in this case because the movement is happening going left and right. It's happening in the horizontal. So we're only going to be looking at, and let me just highlight these ones. We're only looking at these forces right here. That's the only ones that we're concerned about. So in this case, your formula for tension would be the force of tension is equal to your kinetic force, but it's in the opposite direction, so it's going to be negative. So these are just a couple of examples on how to analyze the tension force. Now, let's say that we had an angle associated. So let's draw in, let's say we have a box or a sled. Let's say that this is a sled. And the sled is being pulled in this direction. So there's an angle associated with this right here. This is our tension force. And let's just say that it stays on the ground. So it's staying on the ground, it's being pulled along the ground, so the motion is in this direction right here. We have our friction force in this direction. And we want to be able to calculate our force of tension. Now the thing is that not all of the tension force is acting in the horizontal. We have here an angle associated. So this force right here, actually let me color that in a different color. Let's go with blue. This force right here, this is your x component of this force. Now how do we get the x component? Remember, your x component is equal to your force times the cosine of your angle. So in this case, this is your ftx. So, like we did the last time, your ftx is equal to your kinetic force, opposite direction. But now we need to substitute this one in. We're going to take this here and put it here. So this is going to become ft cosine theta is equal to negative fk. And then this is the base formula that you would use to find the tension force that is required to pull this sled. So once you have figured out your formula, then it's very easy to solve for your tension force. So let's give this example some numbers. Let's say that my Fk is equal to negative 35 newtons. And let's say that my theta is 30 degrees. So if I wanted to calculate my Ft, actually let's rearrange this. So Ft would be actually equal to negative Fk divided by your cosine theta. So I'm going to take this over here. So negative 35 over cosine theta. When I calculate that, and make sure that your calculator is in degrees and not radians, this will give me a tension force of 40.4 newtons. So this is how we deal with tension. Thank you for listening, and I will see you next time when we start talking about how to draw free body diagrams like this one, similarly like this one here.